Good morning, friends. So, I am Dr. Alok Agarwal, and this is your 14th lecture of course Internal Combustion Engine having code ME501. So, in last class, we have seen that what is the difference between a standard cycle and actual cycle, and we have seen its effect, and we have also analyzed the real cycle. Now, in this topic, in this class, we will study first law analysis of IC engine and engine performance parameter. So first we will see that first law analysis of engine cycle. That is first law means thermodynamic. First law we will apply on IC engine, and we will see that what we are getting. Next, there are various engine performance parameters. So in today's class we will go through only efficiencies. Okay, what are the various efficiencies associated with your IC engine? Now to start with first law analysis of engine cycle. So first law, thermodynamic first law, what it says that energy can neither be created nor be destroyed. It can only be converted from one form to another. Okay, so this is the first law of thermodynamics. Now with this statement, we will apply this statement in our IC engine. So what we have to do, according to this statement, what we have to do, we have to do that we have to balance the whatever energy is coming inside the IC engine and whatever energy is going out of from the IC engine. We have to make the balance between the two. Okay. So let's start. In IC engine, first what is happening? First, the fuel will burn, and it will convert. After burning, it will convert and it will produce very high thermal energy. Okay. So energy of fuel will be converted, means chemical energy will be converted into thermal energy, and that liberated energy, whatever the energy liberated from the combustion of fuel, it is not possible to utilize the total energy on the piston, driving the piston or driving the vehicle. So there are some sort of energy, some amount of energy will go in some other form, and we cannot convert the complete energy of the fuel, what it is producing, to convert it into the mechanical work. Okay. So in this section, we'll see that after producing energy, what are the different form of energy that will be go unutilized, and where it will go, and finally what energy we'll get as power output. Okay. So first of all is indicated power. See, what is indicated power? When the fuel burn and it produce energy, suppose it produce x amount of energy, and from that x amount of energy, some amount of energy will go or will lost in engine exhaust. As we have seen that the temperature of the exhaust gas is also higher than the ambient temperature, so it has some energy associated with it. Some energy will go through the coolant. Continue, there will be the movement of coolant around the combustion chamber or around the cylinder. So there will be some amount of energy carried away by the coolant, and there are some laws due to radiation, because every body which has certain temperature will radiate heat. So inside the IC engine there will be a huge temperature, there will be a very large temperature, so it will radiate energy, and because of that radiation there will be some losses. So the energy which is converted to power after reducing this energy from the fuel. Okay, fuel is producing X energy, we are reducing the energy which is getting lost in the form of exhaust gas, coolant, and radiation. Then the remaining energy, we called it as a indicated power, and this energy is utilized to drive the piston. Okay, so so indicated power is the amount of energy which is utilized to drive the piston, and this energy will always be less than the energy liberated by the fuel. Okay, so here once come that total fuel energy minus energy lost in exhaust gases, coolant, and radiation will give indicated power. Next one is brake power. Once the indicated power we obtained, which is used to drive the piston, then the total energy what we are getting as indicated power will not be 100% converted to drive the vehicle. Okay, which is not the output of the engine. So that comes the brake power. The energy received by the piston will pass through the connecting rod to the crankshaft. Okay, whatever energy is getting by the piston will be transferred to the crankshaft via connecting rod. And in this transmission, there are certain losses, like that is losses due to bearing, friction, pumping loss, etc. There are various losses occur, and all this, and only a part of energy is utilized at the end. Also, there are certain energy utilized for driving the auxiliary devices like feed pump, valve mechanism, ignition system, etc. Okay. After deducting all the losses, the energy available, whatever energy available as output, whatever mechanical energy available as output is called brake power. Okay, this is our brake power. So we can see that, and the energy lost in friction, or the energy lost uh, from conversion of energy taken by piston to the output power is called friction power. The energy lost due to friction is called friction power. So if we compile it, what we are getting first energy from fuel, then we are getting indicated power. Then when we subtract friction power from indicated power, we get brake power. So we can write this formula that indicated power minus brake power is equal to frictional power. So this frictional power is very important. It is like we have to reduce this friction power to get more brake power. Okay. So this is the first law analysis of engine cycle. Now the performance parameter. So there are different type of efficiencies. We will first start with the efficiency. So first is thermal efficiency. So what is thermal efficiency? Thermal efficiency determines how efficiently the fuel is being utilized. Whatever fuel you are utilizing, how efficiently you are utilizing that fuel. Means what is the maximum amount of energy you are taking from that fuel. Again, this thermal efficiency is divided into indicated thermal efficiency and brake thermal efficiency. So indicated thermal efficiency is the ratio of indicated power to the fuel energy. Indicated power, and in denominator there will be fuel energy. Fuel energy means mass of fuel burn into calorific value of fuel. Now calorific value of fuel we will study in coming slides. But for now, calorific value you can say that the amount of energy released when unit mass of fuel burn. Okay, this is called calorific value. So when we multiply that, the amount of energy produced by unit fuel into the mass of fuel, will get total energy produced by the fuel, that is in denominator, and indicated power is in numerator. So we will get indicated thermal efficiency. Similarly, if we change the numerator from indicated power to brake power, we will get brake thermal efficiency, which is the ratio of brake power to the fuel energy. So these are the two thermal efficiency, that is indicated thermal efficiency and brake thermal efficiency. Next one is mechanical efficiency. It is the ratio of brake power to the indicated power. Okay, mechanical, because there are losses when indicated power is transmitted to brake power. There are some mechanical losses. That's why it is called mechanical efficiency. So mechanical efficiency is the ratio of brake power and indicated power. Again, we have seen that this indicated power can be written as brake power plus frictional power. So we can write this mechanical efficiency as a brake power divided by brake power plus frictional power. Okay. Now see, there is certain relationship between these three efficiency: brake thermal efficiency, indicated thermal efficiency, and mechanical efficiency. Here it has been seen that it is brake power upon indicated power. So mechanical efficiency can also be written as brake thermal efficiency by indicated thermal efficiency, because denominator of both the side will cancelled out, and brake thermal efficiency, brake power will remain there, and from indicated thermal efficiency, indicated power will remain there. So we'll get a relation between these three. So in numerical problem, it is very helpful that two efficiency will be given, and if it is our third efficiency, we can easily calculate it. Okay. Now there is one other efficiency, that is volumetric efficiency. It is defined as the engine output is limited to a maximum output of air. Okay, so can be taken during the suction stroke. So engine output is dependent upon the amount of air or charge taken during the suction stroke, because only a certain amount of fuel can be burned effectively with a given quantity of air. Okay, so we can burn certain quantity of fuel with a given quantity of air. So the amount of air taken inside the combustion chamber is a very important parameter. This volumetric efficiency, what it indicates? It indicates the breathing ability of the engine, and it is defined as the ratio of air actually inducted at the ambient condition to the swept volume of the engine. Means what if we want to understand it in a very simple language, we can say that volumetric efficiency is the ratio of actual amount of air, actual volume of air taken inside the combustion chamber during suction stroke to the maximum amount of air, maximum volume of air that can be taken inside the combustion chamber. And what is the maximum volume of air taken? That will be equal to the swept volume. Okay. So volumetric efficiency is the actual volume of air taken during suction stroke to the maximum volume taken during suction stroke, that is stroke volume. So this is denominator is fixed. It depends upon the numerator. Volumetric efficiency vary from it will be always less than 1. Okay. The final one is relative efficiency, the last efficiency. So it is the ratio of thermal efficiency of actual cycle to the thermal efficiency of ideal cycle. So thermal efficiency of ideal cycle, we have seen in case of when we are studying air standard cycle, what will be the thermal efficiency of Otto cycle, that is 1 minus 1 upon r to the power gamma minus 1. So that is the thermal efficiency of ideal cycle. And what is the thermal efficiency of actual cycle? We have seen just in previous slide that there are two types of thermal efficiency of actual cycle, that is brake thermal efficiency and indicator thermal efficiency. So depending upon in what respect relative efficiency is required, we will use either indicator thermal efficiency or brake thermal efficiency. Okay, so this is about the efficiency, various efficiency. First we have seen thermal efficiency. It is again divided into two parts, that is brake thermal efficiency and indicator thermal efficiency. After that we have seen mechanical efficiency. We have established the relation between brake thermal efficiency, indicator thermal efficiency and mechanical efficiency. After that, very important volumetric efficiency we have seen, and we have seen that it defines the breathing ability of the engine. Then we have seen relative efficiency. Okay, so this is for today's class. In next class, we will study the other parameters that we have left till now. Okay, so thank you.